the minimum number of times a fair coin must be tossed so that the probability of getting at least one head exceeds 0.8 is. Alright, let's say we toss a coin, a fair coin once. What is the probability of getting a head? 1 by 2. Or more interested in tails, let's say what's the probability of getting a tails? 1 by 2 if I toss it once. If I toss it twice, 1 by 2 whole square. If I toss it thrice, 1 by 3 whole cube. If I toss it 4 times, the probability of getting a tail is 1 by 2 whole power 4, right? Now, if I toss it n times, what is the probability of getting a tail every time? 1 by 2 whole power n. So let's say I took a fair coin and I tossed it n times. Each time I got tail only. What is that probability? 1 by 2 whole power n. All tails. Now, what is the probability that I'll get at least one head? 1 minus probability of getting all tails. 1 minus probability of getting all tails is equal to probability of getting at least one head. 1 or 2 or 3 or all heads. All those cases are included, right? 1 minus all tails equal to some heads, at least one head. Now, this probability should exceed 0.8. Okay, this is what we have. 1 minus 1 by 2 whole power n is greater than 0.8. 0.2 is greater than 1 by 2 whole power n. Cross multiply. 2 power n comes here, is greater than 1 by 0.2. 2 power n is greater than 1 by 0.2 is nothing but 5. 2 power n is greater than 5, which is the next power of 2. 2 square, 2 cube. 2 cube is 8, correct? So n has to be at least 3. When n is 3, 2 cube, 8 will be greater than 5. So what is my question? The minimum number of times you should do this so that your probability exceeds 0.8 is option 3. At least 3 trials, right? You have to toss it at least 3 times. Next question. Let a1, a2, a3 be 3 distinct real numbers in geometric progression. Alright. If the equations a1x square plus 2a2x plus a3 is equal to 0. Alright. a1x square plus 2a2x plus a3 is equal to 0. Alright. Now a1, a2, a3 are in geometric progression. So I can say a1 into a3 is equal to a2 square, right? So obviously product of the first term and the third term should be equal to the second term. What else can I say? If the first term is a1, the second term should be a1 into r, the third term should be a1 into r square, correct? Where r is the common ratio of this geometric progression, right? a1, a1r, a1r square. So let's substitute that here. a1x square plus 2 into what is a2? a1r into x plus what is a3? a1r square is equal to 0, correct? Now I can see a1 cancels out a1, a1, a1. When I cancel out, what do I have? X square plus 2rx plus r square is equal to 0. Now how could I cancel a1 knowing whether or not it can be 0? See, a1, a2 and a3 are distinct real numbers. Now the moment one of them is 0, right? Now the moment one of them is 0, all of them will be 0. Here it's mentioned that they're distinct. Therefore a1 can't be equal to 0. Now what is this? This is nothing but x plus r whole square equal to 0. X plus r whole square equal to 0 means x is equal to minus r. There are two roots, but both of them are equal. X equal to minus r, where r is the common ratio. Where r is the common ratio of this geometric progression, right? Now, what do we have? a1, a2, a3. These are in a common ratio where a1, a1r, a1r square, these are the 3 terms. Further, what do we know? That quadratic equation, the first one and the second one have a common root. Common root meaning the first one has 2 roots and both of them are equal, which means r or minus r is a root which satisfies even the second equation, right? So in place of this, if I substitute minus r, I should still be able to satisfy the quadratic equation, right? Let's do that. So here The common ratio here is r, and the same r minus r is the root of this quadratic equation b1x square plus 2b2x plus b3, right? So b1 into minus r whole square plus 2b2 into minus r plus b3 is equal to 0. So b1 into r square plus 2b2 into minus r plus b3 is equal to 0. So what do we have here? These three terms are a1, a1r and a1r square, right? So r square is the ratio of the third term and the first term, correct? b1 into, so instead of r square I'll just write a3 by a1 plus 2b2 into, instead of r I'll just write the second term by the first term, a2 by a1, right, plus we can just write a3 by a2, right, so that we'll get as many terms here because we have a1, a2, a3, everything here in the options, plus b3 is equal to 0. So what do we have? b1 by a1 into a3 plus 2b2 by a2 into a3 plus b3 is equal to 0. I have b1 by a1, b2 by a2 and a3 is common here. Let's just cancel a3. Let's just divide the entire side by a3, right? What do we have? b1 by a1 minus, okay, this is minus, this was minus, b1 by a1 minus 2b2 by a2 plus b3 by a3 is 0. So b1 by a1 plus b3 by a3 is equal to 2 times of b2 by a2. So what do we have? A plus C is equal to B. So b1 by a1, b3 by a3 and b2 by a2 are in an arithmetic progression, right? The sum of the first term and the third term is equal to twice the second term. So that's option 2. The equation x square plus y square minus 2x minus 4y plus 5 equal to 0 represents. Okay, let's try to complete. It looks like the equation of a circle, x minus 1 whole square plus y minus 2 whole square. This is 1, this is 4, 5 satisfied, this is 0. All right. So we have the equation of a circle whose radius is 0. What does it mean? It is a point 1, 2 without a radius. So this equation represents a point in space and the coordinates are 1, 2. Next question. The probability that a randomly chosen positive divisor of 10 power 23 is an integer multiple of 10 power 2001 is. Alright. So 10 power 23 2023 can be written as 2 power 2023 into 5 power 2023. Right. Now, how many positive divisors will it have? It will have a power p into b power q, correct? So the total number of factors is 2024 into 2024, so 2024 square. The denominator will be 2024 square. Okay, option 2 or option 4. Looks like 1 and 3 are eliminated right away. Now what will be in my numerator? I need to find this factor which is also a multiple of 10 power 2001. Okay, how does that work? 10 power 2023 by 10 power 2001. So what does it give me? That gives me 10 power 22, which is 2 power 22 into 5 power 22. So how many such factors will this have? So how many multiples of 10 power 2001 will be factors of 10 power 2023? This will be 23 into 23, 23 square or 529, right? How many out of the total factors of 10 power 2023, how many are also multiples of 10 power 2001? That's what we're trying to find out. And there are 529 such, 529 or alright, we're leaving it at 23 square by 2024 square. So you can also imagine it like a Venn diagram actually, right? So here in this region you have 529 factors. Here we have multiples of 10 power 2001 and here you have factors of 10 power 2023, right? So there's an overlap. There are 529 numbers which are multiples of this as well as factors of that. You could pick any of those 529. Upon the denominator, you can pick any of the factors of 10 power 2023, right? Next question. Let greatest integer function of x denote the greatest integer not exceeding x. All right. So how does that work? We call this greatest integer function. Greatest integer function of 7.8 would be 7. The greatest integer not greater than 7.8, right? Which means the integer just slightly lower than that. Greatest integer function of 8 would be 8. Greatest integer function of 9 would be 9. 9.2 would be 9. Slightly less than that, right? And what is this? This is x is equal to x minus greatest integer function of x. So this is nothing but greatest integer function of x, greatest integer function. And what about this curly bracket x? This is nothing but fractional part of x, right? Imagine my number x is 7.8. What is this? 7.8 minus this would be 7. 7.8 minus 7 would be 0.8, correct? So this represents the greatest integer function less than or equal to x, and this represents the fractional part of x. All right. Now, if n is a natural number, then the sum of all values of x satisfying the equation 2 greatest integer function of x is equal to x plus n times a fractional part of x. All right. So 2 greatest integer function of x is equal to, what is x? X is greatest integer function of x plus fractional part of x. Yes or no? Any number is equal to the greatest integer part plus the fractional part. For example, if my number is 8.2, greatest integer function is 8, fractional part is 0.2, 8 plus 0.2 is 8.2. Now if my number is an integer, greatest integer function of 9 is 9, and there's no fractional part. 9 plus 0 gives me 9. So that's what we are applying here. X is equal to greatest integer function of x plus fractional part of x plus n of fractional part of x. So 2x, x cancels. Greatest integer function of x is equal to fractional part of x plus n times fractional part of x, or greatest integer function of x is equal to n plus 1 into fractional part of x, right? This is what we have finally. Now the question is sum of all the values of x satisfying this equation. All right. So how many values of x actually satisfy this equation? That is what we're trying to do. So here we're looking for the sum of all the values of x, right? And what is the value of x? X itself is equal to greatest integer function of x plus fractional values of x, correct? Now let's take this result here and see. Greatest integer function of x, this will always be an integer, is equal to n plus 1 into fractional value of x, correct? Now greatest integer function, the left hand side will always be an integer, correct? So this will be 1. If this is 1, what will be the value of fractional value of x? X has to be 1 by n plus 1. So this is greatest integer function and this is fractional value. If this is 1, this will be 1 by n plus 1. What if this is 2? This will be 2 by n plus 1, right? This is 2, this is n plus 1. Fractional value of x should be 2 by n plus 1. If this is 3, this will be 3 by n plus 1. So on till if it is n, the fractional value of n will be n by n plus 1. Now, can greatest integer value of x be n plus 1? No. Because if this is n plus 1 by n plus 1 will give me 1. The fractional value of x, it is the fractional value, it is the decimal part, it can't be 1. It should be at least 0.0000 something 1. It can at most be 0.9999 so on, 9 bar. It can't be equal to. So the next value, greatest integer of function, can it be n plus 1? If that's n plus 1, this will be n plus 1 by n plus 1, 1. Fractional value can't be 1. This is ruled out. So these are all the possible values of greatest integer function x and fractional value of x. Now that we've come there, what is the next step? We are being asked to find out the sum of all the values of x. But hey, what is x? is it not greatest integer function of x plus fractional part of x, which means the value of x is this plus this plus this plus this plus this plus this plus so on till this plus this. Add up all the terms, meaning add up all these terms 1 plus 2 plus 3 plus so on till n. This is n into n plus 1 by 2 plus what about this 1 by n plus 1 plus 2 by n plus 1 plus 1 by n plus 1 3 by n plus 1 plus so on. So 1 by n plus 1 into 1 plus 2 plus 3 plus so on till n, which is n into n plus 1 by 2, right? N plus 1 cancels. You have n by 2 here, n by 2 here. N by 2 into n plus 1 plus 1 equal to n into n plus 2 by 2. This is what we finally need. N into n plus 2 by 2. That's option 3. We found out for fixed n plus 1, we found out the value of greatest integer function and fractional value of x, and then we added all these values and then we got n into n plus 2 by 2. Next question. The set of all real values of x satisfying this inequality. As we always do, we try to ignore the denominator, and what do? We make it a perfect square. We multiply numerator and denominator with x minus 1. Then x minus 1 becomes x minus 1 whole square. We don't have to worry about that. Similarly, same thing with 2x plus 1. Multiply and divide by 2x plus 1, 2x plus 1 and 2x plus 1. Right? So my denominator will be x plus 1 whole square, 2x plus 1 whole power 4. It will have to be non-negative. It can't be negative. Now I can only focus on the numerator. X square into x plus 1 into x minus 1 into 2x plus 1 greater than 0. This is x square will always be non-negative, so I don't have a problem with that. Let's focus only on these 3 points. What are the 3 main points? This is 0, this is 0, this is 0. So what do we get? X is equal to minus 1, x is equal to minus 1 by 2, and x is equal to 1. Right? Now check beyond 1. Beyond 1, see, the inequality here is not greater than or equal to, it is greater than. It can't be equal to 0, right? So x can't be 1, greater than 1, this will be positive, this will be positive, this will be positive. So it satisfies here. So automatically I know it won't satisfy here, and it will satisfy here, it won't satisfy here. We know that it goes like that, correct? So what is this range? It is true for a minus 1 comma minus half, and it is true for 1 comma infinity. So that would be option B. Why not minus half? Check the denominator. 2x plus 1 can't be 0, right? I have only greater than, no equal to, greater than or equal to or anything. 2x plus 1 can't be 0, so x can't be minus half. Similarly, the numerator, I want x plus 1, this to be greater than 0, so I can't have minus 1. If it is minus 1, it will be equal to 0, right? Option 2, moving on. Which of the following straight lines are both tangents to this circle? Okay, what is that circle there? X minus 3 whole square plus y plus 2 whole square, right, is equal to 12. 12 carried to the other side. 3 square, 9 square, 9 plus 4, 13 plus 13. So what do we have? X minus 3 whole square plus y plus 2 whole square is equal to 25 or 5 square. All right. So this is a circle with the center at 3 comma minus 2 and a radius of 5 units, right? Now, all these lines look very familiar. All of them look very similar, right? 4x plus 3y is common. So that's really easy. Okay, let's assume 4x plus 3y plus c equal to 0 is the equation of the tangents, the two tangents which are tangents to this circle. All right. So what do we have? 4 into 3. Now we know the distance is ax1 plus by1 plus c by root a square plus b square, correct? So 4 into 3 plus 3 into minus 2 plus c by root 4 square plus 3 square, 5, should be equal to the length of the radius, correct? Because we know this is how a circle is, this is how two tangents would be. This one would be at a length of 5 units, this one would be at a length of 5 units, correct? So this has to be equal to a radius. So what do we have? 4 3s are 12, 12 minus 6 is 6, 6 plus c, mod of 6 plus c is equal to 5 5s are 25. So mod of 6 plus c can be 25 or minus 25. So c can be 19 or minus 31. So 4x plus 3y plus 19 and 4x plus 3y minus 31. 17th one, we're going with option 2. Next one. If log sin x to the base cos x plus log cos x to the base sin x is equal to 2. Alright. Log sin x to the cos x can also be written as log sin x by log cos x. And the second one can be written as log of cos x by log of sin x, right? This is equal to 2. Now, this is log of sin x by cos x. If I write this as x, log of sin x by cos x, this is log of cos x by sin x. I can write this as 1 by x. X plus 1 by x is equal to 2. Now, clearly both of them are positive, right? Now, we know this inequality that x plus 1 by x is greater than or equal to 2 as long as x is real and positive. It's at least equal to 2 and it will only be equal to 2 when both are equal, right? Which means x is equal to 1. This is 1. What does that mean? Log of sin x by log of cos x is 1. Means log of sin x is equal to log of cos x, or sin x is equal to cos x. When will sin x be equal to cos x? In the first quadrant, when they're both equal, right? 45 degrees. X is equal to pi by 4 or 45 degrees. What are my options? Okay, pi by 4, yes. Alright, so sin x and cos x, in the first quadrant they are equal. In the second quadrant, cos would be negative, right? So we can't have that happening. So when will they again be equal? After one whole rotation of 360 degrees. So after 2 pi radians. So 2 pi radians plus pi by 4. 2 pi radians plus pi by 4. So we'll go with option 1.